Well, hi, and thanks for joining me here in my shop. So if you've been watching the last few videos on this radio, you know I've been chasing a problem with some popping and crackling that goes on in the radio. And it's all focused around the detector tube, the detector stage, and the related components, which for the life of me, I think I've gone through more than enough to prove it's none of this, including the socket. The last thing that has been rolling around in my head. The reason I don't think it's the socket is because the nature of the noise doesn't change no matter what you do mechanically to the socket. I can grab the terminals and wiggle them and do all that kind of stuff. I don't think the problem is here. I don't think it's in the radio. I think the problem is over here. And I thought this up last night. Yes, in my own little head I thought this up. Let's jump on the schematic here and I'll show you what I'm thinking, and then we'll go and try to find out if that's really the case, because I've been wrong every other time. Yeah, just before we look at the schematic, the breakthrough in my head, if this is a breakthrough, came when I was thinking about why it is I pull the tube out, the popping disappears. I put the tube in, the popping returns. And I've tried to figure out how can that possibly be. And it's a very curious thing. If the popping is not coming out of the tube itself, why removing it would stop it? If it's a leak on this terminal, if that's where the popping is, some kind of corrosion, leak of voltage down here, then why would it stop when I pull the tube out? Because the voltage stays here. It's coming in on this wire. It's still going to be here. Still going to be pushing on whatever corrosion or whatever it is that might be down in there, but the popping stops. And the breakthrough came when I realized when you put the tube in, you start some current flowing. Oh, some plate current flows. Some current flows in this wire supplying the plate voltage to the tube. Pull the tube out, no current flow. No current flow. There's a 40 volt B plus here, but the radio's power supply produces a couple hundred volts. So somewhere 150 volts is being removed, consumed, or dropped before it gets here. Now that's got to be occurring across a resistor. A resistor through which the current is flowing to reach this plate. A resistor through which the current stops when I pull this tube out. The voltage across the voltage dropping resistor will change then from 150 volts to 0. It would read full B plus on both sides. There'd be no electrical pressure inside the resistor to cause any kind of arcing or show up any kind of failure in that resistor. That's my theory. It's a great theory. It's really great. If this if this doesn't work out, then it will remain a great theory. Okay, let's go look at the schematic here and see if I can apply my theory right to the schematic here. Okay, so the part we're so interested in is right in here. This is the detector tube, the 227. So here's the little coil, here's the capacitor. Now currently this capacitor is out of the circuit and I have a brand new one stuck in here to eliminate this. Let's just follow this. So with the radio switched to radio, come down, follow this wire, come down here, go through here, other side of the connector, we go through the audio output transformer. This is the radio winding, and this one is the Phono cartridge winding. The Phono cartridge doesn't want any DC, and look where this goes. This just goes to ground, to the chassis. So the cartridge works across this coil only. Now the radio, the 227, needs B plus, and they sneak it through this coil. Let's keep going. So here we see capacitor to ground. He could be the problem. And there it is, R11. That's the guy. If we go further, we see it's coming right to full output of the power supply. It looks like full output of the power supply to me. Whatever it is, B plus, I don't know now, 200, 250, I can't remember. This guy is potentially dropping, funny pun there, potentially dropping 150 volts. That's quite a strain across it. So we got to find these two parts and test them. But I have an alternative test before I start turning my bench upside down, because this is not easy to get to. I'm going to pull this tube out. Well, first I'm going to turn on the set and make sure it's popping, because at the end of yesterday's session it just stopped popping. So for crying out loud, you better pop when I turn you on. It'll be popping. I'll pull this tube out, and then I'm going to take a resistor and attach it right up here and stick it to the ground. Stick it to the ground. In my head, I've worked this out to be around 5,000 ohms or so. This will initiate a current flow similar to what the tube is doing. And that current flow, if there's a problem back over in this resistor, the popping will start. That's my test theory. Otherwise, I'm going to have to really get access to this resistor, literally replace it, and then see what happens. That's probably a more direct. Well, I want to be sure about things here, so okay, let's try the experiment. There we go. So we're hooked back up here, so the radio should work just as it always did. Tubes are in. Will you pop? You better pop. Excuse me there. Sorry for reaching right in front of the camera, but my shop is only so big. Here we go. Pop for me, radio. There we go, full power. Just do some popping. What's with the hum? Come on, do some popping. Oh, you son of a gun. It's a very strong hum. I don't remember there being a hum like that before. What's that, 2 changes? No popping and some hum. Maybe it's just tuning. I don't know, it's right in there. Ay. Okay, let's flip it over to Phono. Why is it humming? It didn't hum like this before. Come on, I want to trade one problem for another. This is a really sneaky radio. Just before you catch him, he's like a chameleon. You change. The tuning is really difficult on this radio. A little experiment here. Let's do a little experiment. Maybe we'll start popping soon. Aha, this one gets louder. Wait a minute. I can do these by hand. Oh yeah. It's interesting. Get to feel the mechanism here. Okay, so listen to that hum. I did fill it with this hum control. No. The hum is there when it's on Phono. Well, I don't know. Something else is there. And the radio got so quiet. Hey, what happened to the hum there? It beat the heck out of the speaker. The hum went way down. Huh. Could the hum and the popping, which isn't here now, could they be related in some way? I wouldn't imagine so. Beating the heck out of that speaker, that's for sure. You know, the reason for beating that speaker up when you throw this switch is you're interrupting the B plus with this switch. Right on the audio line. The B plus is flowing through the audio line here. And I guess, you know, that's basically the case. And I heard a cat. I heard a cat. Okay, hold on a second here. Who's at the door? Is there somebody here? Hello. Are you looking for the other cat? Where's the other cat? The other cat is in the garage. Do you want to go in the garage? Do you want to go in the garage? You want to go in the garage? Oh, my poor cat. Okay, I see. Let's go to the garage. Come on. Come on, Peter. Oh, I don't know if you caught that on camera, but my other cat was already in the garage. And now they're happy together. They will go and play together. Good. Leave me alone. So what do we got here? We got just a continuing weirdness with this radio. You now. I have a different face looking at me now. Go play with Peanut. You can't go outside today. No, you can't go outside today. Sorry, buddy. It's raining. Got an all-day rain here today after quite a few days of beautiful weather. So I was moving these on the basis that if these weren't tuned exactly right, then there's a chance when I pulled it back, there's a 50-50 chance that it would get louder, indicating it's not tuned correctly. If in fact it's not tuned correctly, but you got to push it this way to make it louder, I can't do it because you can only pull it one way. So I'm looking to see if there's some indication that there needs to be adjustment of these, as much as I have convinced myself utterly not to touch any of this stuff. Hey, nothing like more conflict. Let's just try it again. Where did that radio station go? I've noticed this before. When the volume's low, sometimes it seems like all the radio will pick up is noise. Where'd you go, man? That's a good question. Well, I just moved these. Oh, come on. Come on. Let me turn it up more. I just finished explaining how when the volume's low. Yeah, there we are. 640. I'm going to push these in. They don't move at all. So this is quite a little piece of apparatus that they put together here and designed for this radio. Now I'll pull them out again and we'll listen carefully. That definitely gets louder. And then quieter. This one? Yeah, actually just the slightest pull off and it gets louder. How about this guy now? Quieter. Immediately quieter. So this guy's probably too far out. Probably needs to go this way. Yeah, so it could be right on, or also maybe it needs to go in further. This way. Interesting. I'm waiting for the popping. The popping is not coming back. Wow. And I had that great theory. I had this great theory. Theory shot. Now, why the hum? Is it this? No. Not hooked up to anything else except the power supply. Just the AC power supply. No other source of hum. Boy, I tell you, this is another ugly problem. It's an ugly problem. The hum is hard to hear on my signal tracer. The hum is probably coming in at some point. Could be coming in everywhere. Who knows? Depends on what's causing it. Oh my gosh. Again, if we flip it to Phono, now that's the sound, I believe, of an open input. Right here, in fact. If we put a clip across this and short this input out, I think we'll lose that hum. Let's try it. It's not a real hum. It's not a real hum. That's a dumb statement. This should boost it. No. This should kill it. Well, it gives you a different kind of hum. It's a bad day in my shop here. My theories are just melting down around me left and right. So, okay, going back to the popping, which doesn't exist anymore. So I fiddled around here pretty thoroughly yesterday, and then the popping disappeared. Well, I guess we're going to have to assume the fiddling here somehow cleared off the popping. I don't like it, but what else can you conclude? It looks like I still haven't found. I haven't really looked. I haven't found any instructions on how to tune this, but I'm starting to get a wind of it. You know, you tune to one extreme. It'll go all the way over, and that lines this pin up with this wheel, this pin with this wheel, this pin with this wheel. The pins, the screw pins, are pushing. They're like this. How can I show this? This is actually quite clever. I've seen this kind of thing done in a number of circumstances. I'll just use this piece of paper. Okay, so you got to use your imagination now. 5 pins, 4 fingers are those pins. If they just had the pins come through and let them strike this, then as you tune, of course, the wheel is just going to do this, right? It's going to bump along these things. So how do you, would the word integrate be right? How do you integrate these into a smooth travel? And how do you get an average position here between this one and this one, assuming they're turned differently? How do you get that? Well, you put a band of metal across this. So here's the band of metal. I'm going to make it more like a band here. Okay, stick a band of metal. Now, obviously, maybe I can do this. Stick a band of metal, and then you run the wheel here. No, stay up here. Metal. So as the wheel runs over, it's still really being pushed by the screw, but the band of metal is in between. And as the wheel moves, it just moves the metal. It just moves the metal band like this. It goes up and down like that. I think I got it. It's a band of some sort. I don't even know that it's metal. Something in here. It appears to be a continuous band all the way around. Oh, let's get the close-up camera on here, because I just saw another little feature of it, which is kind of interesting. Okay, here's a close-up of some of those adjusting things. You can see how clumsy they are to get your fingers in here. You're not going to do that with your fingers. Probably had a tool made, a very particular tool made for doing this adjustment. Okay, so here's the wheel. You know what I'm going to do? I'm going to turn this radio off before I end up going through the moon here doing this. Holy smokes. There. So what I was doing, of course, I was just grabbing these and moving them like that. Now you can see under here there's a bit of a brownish band. It's a little hard to see. What happens if I tune here? And you can see the action. You can actually see the action in it there. The part that caught my eye was what was going on with the band over here. The spring. So that's how they've done it. So they have, it looks like a copper band, which would be fairly flexible, running all the way through it, coming around the other side. And then it's just sprung to keep tension on it. After all, it's got 4 of these wheels pushing on it. It's got 4 of these things going on, not just one. So you can put a pretty thin band of copper in there. That's probably what that is. It's probably really thin. And that's how it's working. So I think in terms of doing an alignment on this, I mean, again, I have not found, the most I have found is a statement that you should take it to your dealer to have adjustments made if you think there's adjustments needed here. But it looks to me like you would tune to one end. Are you right? Is this right? Oh, I got a cat staring at me here. That's what happens on a rainy day. You would adjust it to, well, you know what? You could adjust it actually to line it up with one of these pins. Like that. That's the extreme end. So I got this lined up. Of course, this will be lined up. This will be lined up. That'll be lined up. Look at this one sticking way out here. We'll then turn on the signal generator, feed in a signal generator, controlled signal, tune the signal generator. Oh my gosh, this is the end of the whole deal here. Okay, I'll let you go ahead, because you're. What else can I do with this cat? So we would adjust these 4. And then we would tune the radio like so. Line these up. Second screw. Change the signal generator so it tunes in. Adjust. And just do that right through the whole thing. Sounds like a valid procedure to me. But maybe there's some trick to it. Maybe you got to start at one end, or I don't know. What do you think? What do you think? She's purring away here. What do you think, Shadow? You think it's that too, man? So I gotta think some more about whether I really want to try that, but it doesn't look so scary to me. Why don't we try turning one of these? I wanted to do that earlier. Let's try it now. And what I'll do is pick a tool here. This is actually a fairly powerful tool here, but we'll try it anyway. Try this one that's sticking way out. What would be involved in doing this? So that's what I'm doing now. I'm assessing what's involved in doing this. Oh wow, that's... Oh! It made a little clicky sound and came loose. Now it feels quite loose. Wow, would I ever have some kind of tool that would fit back onto there? Something like, you really like a... I don't know. Cat walking on my keyboard though. Here, did anything happen? No, still on the air? Still going? Hello? Is that cat a Democrat? What's going on here? Hey. There we go. So, well, once again, start my video thinking one thing and find myself in a totally different headspace from where I started. hum is a little bit of a worry. And the popping, you know, maybe it's gone for good. Oh, and the alignment of this. Well, I'm going to go look and see if I can find some kind of tooly thing I can put on here. And that might encourage me a little bit to go ahead with that. Meanwhile, come with me, cat. You're going places. Here, look in the camera. That's right. It's a strange day already. Okay, with the radio in the state it's in now, not clicking and popping, and working fairly well, and with the knowledge that there's probably some alignment benefit to happen here, I'm going to stop on the radio for a little bit and turn my attention over to the amplifier here. And this is what the owner of this is really interested in. Anyway, he plays records with this. He doesn't listen to the radio. He plays records. So the real interest is in the amplifier, which I've been kind of ignoring for a while I've got myself all balled up in the receiver over here. So until or unless this thing starts popping again, I can't do anything about the pops over here. Maybe they're gone for good, for reasons, who knows. So in the meantime, turn my attention here. Let's test this, guys. My initial intention with this whole thing was make sure this thing's working safely, fool around with the receiver to bring it up to a high level of performance, to get nice clean signals out of the receiver to go back into the amplifier, and then I can return my attention back to the amplifier. So I haven't quite got the nice clean signals coming out of here, but of course this is for playing records, so I can feed a signal into here of my own making, my own choice, and then we can listen to it, we can look at it on the scope. I've already got a scope lead partly connected here. I'm just trying to sort out which of these two wires may be grounded before I finish that. So I think that's the approach I want to take. We'll turn our attention to the quality of the amplifier, and I guess the speaker comes along with that a little bit, and we'll see what we can see with all that. Okay, I think we're set up here to feed an audio signal into where the record player input would be. I've noticed that there's no volume control on this at all. The volume control has to be a control right on the record player itself, kind of oddly enough. So this is just feeding into a wide open amplifier. So to control the signal level, I'll have to use my signal generator here, which I've got set very low to start off with, really low. It's going to sweep between 100 Hertz up to 10 kilohertz. It's going to take 10 seconds to do that sweep, so it's going to slowly be sweeping up in sound so we can listen to it. Now the speaker is face down over here, so I'm going to lift it up so it's no longer face down. Wow, that is heavy. Holy smokes, man. Yes, and it's facing the wrong way, but that's fine. I have my scope connection there. And you'll be able to watch the result on the scope. What we're looking for mainly is indications of a tube being driven into cutoff. Now, the only tubes that are involved in this really is this one and these two. The rest of this is doing nothing over here. Should be doing nothing. If this thing starts to pop and click in the middle of this. Okay. So we are now set here. We're set to phono over here. You can't quite see what I did, but I switched the phono switch on. You know, one of the, I wouldn't say odd things, but one of the things they didn't work out on here was how to run the amplifier to play records and not have all this on, because all this radio stays on completely while you're playing records. You'd think they could have arranged a switch to kill all this. It wouldn't be too tough, would it? But they didn't. So something to keep in mind. I would think, Mr. R, if you never play this radio, you should probably pull the tubes out of it and leave it with no tubes in it. Having said that, I don't know if you can even do that. I don't know. Is that allowed? I don't even know. So, something to think about anyway. Okay, so we're ready to feed the signal in. We're ready to see it on the scope. We're ready to hear it come out of the speaker. And let's go. Okay, I've got a couple grounds on, but I verified that these grounds are not... This is not a grounded deal here on the speaker. Famous last words. Just waiting for him here. Okay. So a little bit of hum coming from there. Okay, let's see if we can start hearing this now. Oh, smokes, what is that? What is that? What was that? You know what, I just got... One of the things I thought about but didn't bother doing was just checking for voltage on this terminal before plugging it into my fantastic machine there. I'm usually pretty good at recognizing where the risks are. Maybe not always. Please don't show any voltage here. That's cooperating. Good. So what was that funny? What was that funny? What was that? What was that funny sound? I didn't turn the scope on. Let's see what the scope shows. Let's disconnect the scope. Maybe something is going on here. I just don't realize it. Let's try that again. That's just not at all what it's supposed to sound like. That should sound like a rising tone taking 10 seconds to rise up. Why in heaven's name would it sound the way it sounded? Heaven's not going to help. I don't have the sweep on. Okay, I don't have the sweep on. That's one reason. There we go. Sweep on. So that's now listen to this at the very start when it starts from the lowest. Listen to what it sounds like. Not so good. The high tones aren't really too much of a challenge for a speaker. So let's just set this to sweep. Just low stuff. That should do it right there. Now we'll listen to this. Wow. Boy, oh boy, oh boy, that's not too good, is it? Well, I'm going to guess that's the speaker doing that. Let's take a look at the, we'll put this back on. Let's take a look at the, look at it on the scope. These are the voice coil connections here. Okay, so some of the stuff that's happening here is there's clearly a hum. My scope is triggering on this hum. But as the other signal comes through, it confuses the trigger a bit. So it's jumping around a little bit, doing all kinds of funny, wobbly things. I don't think we're hearing what we're seeing. I think we're hearing the speaker distorted right up until that moment where it goes clear. You don't see any flat topping or anything here. Okay, let's stop the sweep. And I'll manually control the frequency. So that's where that rumble comes from. That's a really low frequency. It really seems like the speaker is the problem here, because let me make this a little more visible. Yeah, it's so tricky putting this stuff on camera. Oops. Yeah, you know, it's just really hard to get this to show up. There's shutter things going on and everything. But anyway, you can see clearly. Got a hum. Now there's a hum control. I wonder if I can adjust the hum control and make this less. Right, you just see the hum like that. Let me slow this down, make it a little more apparent. It's really apparent now. So I'm going to turn the hum control, and we're going to see what happens. The hum control, let me just show you where this is. The hum control is on the amplifier through the side here. Oh my gosh. How am I going to get at that? I'm going to rotate the amplifier here. Anybody getting hot? No heat whatsoever in it. That's fantastic. This thing weighs a ton. I've got some clip lead power wires there. Got to be careful of. Okay, so here's the two controls: tone, hum. So we want to go after the hum. The tone control has a long explanation in the manual on how to deal with that. So let's take a look at the. Well, watch the scope here. Wait a minute. I'll just make sure you absolutely know what I'm up to. I'm going to go in here like that. Okay. We're going to see what happens to that hum level. Okay, turning. I'm listening. So I've turned this thing. What am I turning? This isn't there. I've gone from basically lock to lock here. Listen to. Wow. Huh. Well, I'd say somewhere in the middle here is where it should be. But wow, that didn't make any real significant difference. Now there's a hum control on the radio. I can't imagine how that affects this. It should not. Where's the hum? Where's the hum control? I've forgotten here for a minute. Hum control. Oh yes, I just remembered. Now the hum control on the radio is really all about the filament in this tube, which is doing nothing. This tube's doing nothing for us right now. But for the sake of experiment, let me adjust that. I'll just return it to where it is. Okay, here we go. Watching. And of course, you don't see anything happening. Let me put it right back where it was. That's not going to do anything. So the hum could be a persistent hum from the filter, bad filtering, and you have to go back after that a little bit. The distortion is probably coming out of the speaker. I can't do much about it. This is not the speaker the owner uses. This is his spare speaker that I fixed up a bit to make it work here for us. Alternate speaker. I can hook up an alternate speaker here. Okay, let me get an alternate speaker ready. Okay, so the first thing I'm going to try is paralleling this speaker, this is not the greatest speaker in the world, but it's not going to have the problems that the original one has. I'm just going to parallel it in. The other speaker I've tipped back on its face again, so to try to quiet it so we don't hear so much from it. But for now, this is connected too. And here's the leads coming from the voice coil. Okay, now the speaker is aimed right up at my microphone, which is right here. That's what you're listening to. I'll make it just this microphone. I usually have a second one going in here, but by the way, that microphone is a stereo microphone. It's really two microphones in one, a left and a right. So this guy's basically pointing up, so you should hear this pretty clearly as opposed to the other one, because they're both going to be making sound. Now I'm going to make the connection here, and you can listen. So what I'm hearing is a slight drop in the output of that speaker, and then this one is sitting here with a nice warm hum in it. Still hear this one. So we're going to turn up the input signal now. So hopefully you're hearing 80% of what you're hearing is coming from here and only a little bit coming from there. I'm sure that's the case. I think I stuck my head in there just now. This is quite a bit louder. Drive down the frequency and see if the distortion shows up in here, which it won't. A little more volume. I've picked a speaker that can't reproduce low sounds very well. So I can hear some distortion there. I think it's the other speaker I can hear still. Just a second here. So again, it's hard to tell the difference. They're both about the same volume. Doesn't make any difference. Well, maybe I've done enough here anyway. Maybe I've done enough. The chances of this low frequency distortion coming from the amplifier is really low. We saw nothing much on the scope in that respect. And it's the kind of sound you get from a speaker that's got problems. This guy's still got problems. But as I said, this is not the speaker the owner listens to. So I can't really deal with a speaker problem that he may have with his own speaker at home. Now he's got more than one of these radios. He's a serious collector. This is not Grandpa's radio. This is a person who is looking for these and has had quite a few, I believe. So he's got some mix and match things to do himself. The question is the amplifier reproducing the sound properly? And is there some problem with it in terms of hum or volume? And I certainly don't think that's the case. I don't think that's the case. The only way to go a little further with it would be to disconnect the voice coil wire and shut the speaker up over here. You have to have the field coil going, that's for sure. It's part of the power supply. But we could quiet that one. Then we just hear this. You know what we're going to hear? It's going to sound great. So what more do I need to do? You know what? I was adjusting the wrong thing on that amplifier. How did I manage that? I'm pretty sure I was adjusting the tone control, which I probably shouldn't have touched. Okay, let's go back and look at this hum again. Son of a gun. Okay, we can hook up right here. A bit of a dumb mistake on my part. There is. I said that little speaker I got doesn't reproduce it very well. Hum control, okay. Stick my screwdriver in there. It's really good. I made sure you saw what I was doing with the screwdriver first time around so you could see the mistake I was making. Yikes, what happened there? Okay, I'm on here. Now, watching the hum on the scope. Oh, more. Less. Oh, look at that. Beautiful. That's fantastic. Right to there. Okay, so interesting. I don't think the hum instructions include looking at an oscilloscope because in 1929 nobody had an oscilloscope in their shop. Fantastic. Tone thing we won't worry about right now. I suppose if I put some music program through this, some kind of regular program sound through the speaker, we'd find out what it really does sound like in terms of, you know, playing something. I got a couple ways of doing that. I'm going to stop and think about that one for a little bit. At this point, we're nearly done with this guy because there just isn't much room for me to do more. Not really. What do you say we just pop that radio back on and see if it's clicking and popping? It'll be our last act here today. Last step. Okay, volume is down. Radio's on. It's got no antenna right now, so is it thinks it's picking up? It can be picking up just from these wires in here. It could be picking them up 3/4 of the way through the radio. They could be going in and then coming out of the speaker. So who knows? But no clicking, no popping. So whatever the heck was causing that is gone away. It's kind of disappointing. Okay, that's it for today. That's enough. That's enough going around, and I don't want to say in circles, but going all over the map here. So now we've got 2 or 3 rainy days coming, so I may generate some more videos out of my shop here. And thanks a lot for watching. I'll ponder my next move with this guy. There may not be much left. There really may not be. We'll see ya.